Welcome to AI and Us, a series where we explore our future together in the age of artificial intelligence. In this episode, we'll be exploring the modern workplace, where AI technologies are transforming how work gets done. We're empowering both users and IT with cutting-edge technology like AI PCs that we'll be talking about. By doing that, organizations can optimize efficiency, inspire creativity, and unlock ingenuity. This conversation will explore how AI is shaping the modern workplace, how the AI PC is a key enabler, and the actionable steps decision makers can make to create an environment that embraces the future of work. I'm David Nicholson with the Futurum Group, and I'm joined by two visionaries, one from Dell Technologies and one from MIT, both who stand at the leading edge of AI. First, Dr. Song Han is an associate professor with MIT's Department of Electrical Engineering and Computer Science. He's credited as a pioneer of efficient AI computing with his deep compression technique, which allows powerful AI programs to run more efficiently on low-power mobile devices. He was named to the 35 Innovators Under 35 list by MIT's Technology Review. And we're also joined by Marc Hammons. Marc is a distinguished engineer and a member of Dell's end-user computing experience technology team within the office of the CTO at Dell. His focus at Dell is to bring together solutions and capabilities such as AI, IoT, or Internet of Things, software infrastructure, edge analytics, and augmented reality to enable Dell's customers to have a unique and differentiated experience. Welcome to both of you.
Thanks, Dave.
Thank you.
Good to see both of you. I want to start, Dr. Han. We use the phrase modern workplace. How would you define the modern workplace vis-a-vis AI moving forward?
Yeah, that's a good question. I think modern workplace should have three aspects: the physical interaction, digitalization, and also artificial intelligence. So we want to enable this kind of workspace that enable in-person collaboration and team interaction, like with smart meeting rooms, with AI-powered cameras, and also bridge this physical and virtual interactions so people can work from anywhere. And digitalization, we want to enable those paperless workflows. Everything is digitalized. You can have mobile and remote access to the work systems from anywhere. And once it's digitalized, you can apply artificial intelligence to automate many tasks like email summarization, data entry, content creation, decision making, etc. And AI assistant will help with generating the insights, writing, planning, making business decisions, and a lot of stuff. So physical, digital, and AI.
It's interesting. You mentioned digitalization. I think those of us who are close to this subject just assume that everything is already digitalized. Didn't we create data lakes in 1962 or something like that? Dr. Han, where are we along this road towards the modern workplace in your mind?
I think we are in the maybe in the middle between all three aspects, right? From physical interaction, that's pretty much well set up. You have remote meeting, and nowadays people work from home very easily from anywhere in the world. So physical and virtual, that's almost there. We're almost there. For digitalization, it's hardly, not everything is digitalized. As you can imagine, there's a huge amount of opportunity, first of all, to get rid of those physical receipts and do OCR, scan everything into a computer. The technology is there. Technology is having very good accuracy using these visual language models these days. The adoption, I think we are getting there. And once we are getting there, for digitalization, we can enable AI, since everything can be automated. Less tedious work is needed for day-to-day processing.
Yeah. So, Marc, from your perspective, once these things are digitalized and once we are using our tools, the subject of AI PCs comes up. It's at the forefront of a lot of these discussions, especially sort of out there at the edge with end users leveraging models. What's your perspective on where we are in this journey towards the modern workplace, and how does the AI PC fit in? We're going to double click on that.
I think it's a bit early on the AI PC front. It's kind of the new kid on the block. We're not newcomers to AI. It's been with us for a while. Most people's experience with AI today is cloud-based, but we're starting to see the emergence of technology that can come down onto the PC and actually work with you, kind of as a companion as you go throughout your day. Um, you may know CPUs and GPUs. They've been there for a while. AI is kind of common on the GPU. Everyone knows that that's where typically an AI workload will run today. But now there's this new kid on the block, the NPU, the neural processing unit. And that's a special piece of silicon that's made its emergence and arrival on AI PCs that's enabling these AI workloads to be there resident on your laptop and your desktop. So what was formerly reserved and only available in the cloud, now it's available, starting to make its way down onto the laptop, onto your desktop, so that it can work with you.
Okay, so what makes for an AI PC is not just a sticker on the back that says AI PC, and I was at Coachella last year. That doesn't make an AI PC. So there's actual hardware involved.
That's right. That's right. Combination of hardware and software. So we're seeing a confluence of both. We're seeing some of the silicon becoming much more performant, much more power efficient, which really matters in a mobility world. And at the same time, some of these algorithms, and it's kind of incredible to me these days, models make news. We're talking like trillion parameter models, 2 trillion parameter models with some of the latest developments. But it's also going in the opposite direction. We're starting to see these small language models start to emerge and make their appearance down on a PC. And those things can run very efficiently on the device for things like image generation, text generation, any kind of collateral that might be assistive in helping you like create some kind of work product.
So I think you could look at this from kind of two different angles. The question of performance at the edge and what an AI PC does for you. But Dr. Hahn, are there other reasons why someone might want to be doing this computation in their own data center versus in the cloud? What are your thoughts about that?
So people want a local deployment either on the edge device or their PC or their on-prem server is because people want to protect their data. Data sovereignty. Sometimes we don't want to share the sensitive corporate data, which might have user information, to the cloud. So having them local would ensure such data sovereignty and privacy. And also good latency and fast, right? With the modern AI chips, we can process lots of the small language models as fast on edge devices. So no matter where you are, like field engineers, they might be traveling to different parts of the workspace. They can also have access to them locally. They are available 24/7.
Yeah, Mark, I've had a little bit of experience with some of the latest gen AI PCs. And I can tell you, I didn't know what I was missing until I experienced what I was missing. You get used to the magic of some of these models working in the cloud, and you're just delighted with the reply to your prompt, the magic that's happening there. When you realize that it's taking seconds and it's not happening at the speed of internet that we're used to, yeah, great. Your AI PC isn't connected to the web. That's fine. But even when it is, your performance is so much better because of this hardware. It makes a difference. It's hard for people to understand until they experience it. There's the hardware, of course, but what's Dell's view on how organizations should get started? So let's say I just bought 10,000 new Dell AI PCs and I'm handing them out. Now what?
Yeah, great question. And it's important. Just getting started is really important because a lot of people haven't really thought through like what the impact of this new technology is going to be and how it's going to assist them throughout their day. We see a lot of things on apps that we use every day, apps like we're communicating on right now that are allowing us this remote collaboration and connectivity. And we've experienced in the cloud how things like transcription, translation, note taking, meeting minute collection, action registers, all those things can be done through the cloud. But now the capability exists to do those things locally. And the great thing about that is there could be a personal twist to what's produced. There might be some context that's really rich, that's fusing some of the other information that's there on your PC, maybe some of the documents you've authored recently, PowerPoints you may have created for that presentation, and it can begin to weave in and fuse some of those things together as it works there locally on your device. So I think bringing the technology down and just experimenting with it, figuring out how it will fit in, because it's not going to be the same for everybody. We all are a little bit different in the way we work. We have different jobs. We serve different roles in the company. So a lot of times it's a matter of figuring out, okay, I've got this great technology. I've got these applications that someone in a particular role uses day in and day out. How can this new AI PC serve them as they work throughout?
Dr. Han, I understand why folks like us get excited and interested in where the work is happening and whether it's a GPU or a CPU or an NPU. And Marc, especially, talking about AI PCs and where they play, it's really important. Ultimately, the end user, I would argue, doesn't care where any of this stuff is happening. They just care that it's available and they figure out how to use it. What does the future look like with this in terms of our interaction with these tools? Whether I'm having my request fulfilled locally on an AI-enabled PC or from someplace in the cloud, what does that look like as we move forward? Do these AI entities take over? Is it a collaboration? What are your thoughts on that?
I think the implication is that in the future, there will be increased productivity and efficiency in day-to-day work. For example, lots of AI PCs will automate those repetitive tasks so that we can focus on those high-value work, such as creating problem-solving, innovative, focus more on the innovative part of the work and do more in less time. And secondly, there will be more and more real-time and on-device intelligence with those dedicated AI chips, with those desktop workstations, such as the DGX Spark, for example, like with NVIDIA GB10, Grace Blackwell super chip. You can have 1,000 AI TOPS per second on a small desktop station. It used to be like you require a whole server like a decade ago. If you do such projection 10 years in the future, it'll be a lot more powerful. A lot of the models we cannot run today on the edge in the future with the combination of algorithm and system hardware co-design, lots of things will be possible in the future. It's clearly super Moore's law. And thirdly, I think there will be a lot of hybrid work and collaboration due to those capability of virtual meetings, autofocus, note-taking, speaker tracking, lots of the live captions, real-time translation. Make people can work anywhere in the world. So of course, there will also be new workflows and new jobs created in the future. So for universities and educators like us, we should be aware of this trend and make a lot of AI roles like prompt engineers, AI trainers, AI model optimizers. A lot of new jobs will be created in the future.
Marc, Dr. Han makes an interesting point. I think it's fair to assume that hardware and software in this space is going to get better, cheaper, faster, stronger as we move forward everywhere. At the core, in data centers, in the cloud, at the edge. It's all going to get better over time. How does someone go about making the decision about where their next AI dollar is going to be spent today? And I specifically mean, we could do a refresh in an organization of folks' PCs and really give them power at the edge to do those kinds of tasks that Dr. Han was talking about, the kind of the efficiency enhancements. Or I could invest that next dollar in subscriptions to cloud-based LLMs. The challenge there is the real cost associated with the processing that's taking place with these models isn't really being borne by customers yet. So how do you help folks decide where to spend the next dollar?
Yeah, great question. I think there's several things you've got to consider. Certainly, like, what's the complement of your organization? What are you trying to achieve? You really got to step back and understand, what are your goals? outlining a plan, a master level roadmap that's going to drive your understanding of AI, maybe establishment of an AI center of excellence. Those types of things are paramount to start with. And then once you understand that roadmap, you can make better decisions about, hey, is it cloud? Is it client? Is it both? Because just like Dr. Hahn said, it's a hybrid story. Long term, the distribution of intelligence is going to be really interesting to watch the evolution of over the next 5 to 10 years. But I think it's a little bit of both. I mean, it depends on the needs of your organization. But if you're someone that's going to be building something custom, you're a large scale enterprise, and maybe you've got a data lake that you need to mine and you want to create some value out of, and you want to train your own model to do that. Maybe you're just fine tuning an existing model or existing model architecture. You'll need some high performance computing to be able to do that. You can definitely take advantage of cloud resources in that use case. But again, you're going to be pushing a lot of data to the cloud. You're going to be incurring a lot of expense in the cloud. You've got to maintain that data. You've got to have network connectivity. It's almost like you're building this big building to support all of this, and then you're paying rent on it. So do you want to do that, or do you want to build that building, own that building, have it be sovereign property where your data's there, it's local, it's yours, it's private? That's an opportunity. Likewise, on the PC side, you can look at, hey, who do I have from a persona perspective that really could leverage this compute? If you've got software engineers, you've got creatives who are creating maybe marketing materials, those types of things, it makes a lot of sense to bring some of that processing power local with those individuals. Maybe you would make a bigger investment in a larger scale NPU that provide more TOPS capacity, like Dr. Hahn was describing, maybe more memory to hold larger models, several models at the same time that are interacting as part of a model pipeline. There's a lot of things to consider. But again, it's all going to be use case driven, and really, you really should pin it to a long-term strategy and plan.
So we've talked a lot about what business leaders and IT leaders think about when they're trying to consider what the next dollar should be spent on in AI, this sort of moving forward. But that forward motion is never unabated. Taking a page out of kind of the physician's handbook, first we must do no harm. There are real risks associated with things like leveraging agentic AI. I mean, we're talking about creating these autonomous agents who are going out, they're going to do things on our behalf. Dr. Hahn, what are some of the sensible guardrails and reasonable concerns that you might have about the future of AI and how we best rein it in?
I think we should define boundaries and also the human oversight, for example, human in the loop design, to ensure AI systems require human validation for critical decision making, especially in domains like healthcare. For example, if a task requires 10 steps in total, the AI agent can do 9 steps and will require a human to validate the last step, make sure it's making the good decision for us.
So, Marc, we love to talk about agentic AI and how it's going to change the world. What do you think in terms of guardrails and pitfalls and concerns you might have about how this whole thing could go off the rails?
Yeah, I think there's a few things that are really key. We talked a lot about data sovereignty, privacy, security. Those things are paramount. I know they're on the minds of just about every customer that we meet with in this domain. And so I think ensuring that you have a good plan around your data, where it is, who has access to it, keeping tabs on that will be really important. Another great thing to think about is identity. If there's an agent, what is the identity of that agent? What do they have access to? What rights do they have? Who do they represent? How do we realize that in a modern world amidst what could be an ocean of agents that are working together at any given point? It's a really, really interesting thing to think about, and something that I think industry is working hard to tackle.
So a lot of folks, when we think about traditional IT environments, when you say compression, when you say we're going to make it smaller, we're going to make it fit, often the first place people think, well, it depends who you're talking to. Some will think of the amount of storage that's required. So literally, how much space does the model take up on the laptop in terms of storage? And then, of course, there's memory resource utilization. people nod their heads and act like they completely understand when someone refers to the size of a model in terms of parameters and things like that. But can you characterize? So, Marc, let me ask you, Marc, how big is one of these things as a file? I know it's sort of a random question, but if you're asking, can it fit on my laptop? If it's 57 terabytes, the answer is no.
Yeah,
How big are these files? I have a little bit of experience with this, but what are
sure.
you looking at installing? If I get an AI PC from you, how big is the model? How much space is that taking up? And then how much memory does it need?
Yeah, sure. A rough estimate is typically about a gig per billion parameters. So these things are mini gigs, right? If you start with like a 4 billion parameter model, that's typically going to be around 4 gigs, which is almost as big as the OS size for most PCs that are maybe running Windows. And so they're not insignificant. But thanks to Dr. Han and some of the work that they've been doing in research, and he really I can't underexpress like some of the phenomenal things that he and his team have been producing in terms of like optimizations around even KV cache, the context window, the context link, super important. Because as that thing grows, your resource consumption varies quadratically with that. So it gets really exponentially difficult to really make use of resources as you get a larger context window. As he's been, leaning in and actually optimizing these things, we've seen a tremendous reduction in the in the amount of space that's required in terms of memory footprint on disk as well. Typically, we'll see maybe a 7 or 8 billion parameter model on a conventional AI PC. We've got some higher end AIPs now that have a discrete NPU, I think of it as a plug-in card that you can plug into a system where we can put models up to 109 billion parameters. So that's Llama 4 Scout. It's one of the newest models that's out. It's a mixture of experts models, highly efficient, making use of a subset of experts. Among the 109 billion parameters, there's roughly 16 experts active, about 17 billion parameters for each token that's generated as it runs through the model. So we've seen some really phenomenal improvements lately. But you're right, space matters. Memory matters, memory bandwidth matters. The ability to move data is paramount. And that's why these quantization techniques, the different data formats, they're all extremely important. And it's a multifaceted problem when it comes to the optimization and performance of these models.
Well, Dr. Han, how would you characterize the sort of state of the art when it comes to this balance of precision versus performance? So the efficient use of resources, if you have a model that's in the simplest of terms, only consuming 1 gigabyte or 2 gigabytes of storage and only has a limited amount of memory resource, what are we giving up today instead of precision? And then how long do you predict it will be before this won't matter? Where the question of, well, wait a minute, can you run this model that previously could only be run in a data center on a laptop? We've all heard the stories. People can hold up their mobile device and say, 1,000 times the compute power required to go to the moon. And so as we look towards, say, 2030, which isn't as far away as we might think it is, what do you see in the future for PCs? And at what point do we get to this question of compression and efficiency not being as important, at least in the sense that you're making a sacrifice?
Yeah, I can comment about how much compression we can do. So not to mention 2030, just nowadays we can easily compress a model from 8-bit precision to 4-bit precision, especially using an NVFP4, NVIDIA's floating point 4-bit format, pretty much without losing accuracy. We have several demos like SVD Quant, Nunchaku, those demos to generate images, to deal with language models, just using 4-bit to represent each weight, such that previously 1 billion parameter is roughly 1 gigabyte if you use 8-bit, but now it takes only half a gigabyte. So that's almost pretty mature with respect to technology-wise, and is being adopted by industry very fast recently. And we do see other opportunities beyond quantization, such as sparsity, like the attention mechanism, which is the fundamental technique behind transformers and all the amazing AI applications. But human don't need to attend to everything, right? You only attend to important stuff. Don't attend to unnecessary stuff. So by using that, we can save a lot of compute to process those inference. So using sparse attention, and use sparsity in the KV cache, since we don't need to remember everything in the back, right? We can selectively, smartly remember some of the stuff in the KV cache. That can save a huge amount of memory, and also load some of the KV cache upon needed, only on demand. Load some of the KV cache in the GPU memory and leaving some of them just in the CPU memory. We can also use big model and small model work together to do like self-speculation. Use a small model to speculatively guess the answer, and use a bigger model to verify it from time to time. If the guess is correct, you can gain a lot of speed up and efficiency improvement. So those are some of the examples we can drastically accelerate the AI models these days, given a fixed AI model. And there's even more opportunity to design those efficient models to begin with, given the insights I just shared, right? So for example, designing models that doesn't take O(n) square complexity, but linear complexity, using linear attention, right? And doesn't sacrifice the accuracy, right? And share some of the KV has to minimize the memory movement, okay? And to design models that can enable parallel decoding, okay, to improve the hardware efficiency. So I see lots of opportunity already done, to be done. So like you mentioned, by 2030, there will be a lot of boom in this industry. A lot of cool applications will come to everyday's life, particularly those highly specialized AI models that does one job or a few jobs or a domain of jobs super well. And you can distill a very efficient model catering a very vertical domain of applications. That is even more promising.
If you had to predict one significant advancement over the next 5 years, go ahead and be crazy. What do you think? Gelatinous biostorage, reverse engineered alien technology? What can you share with us?
I would love to see all of those. So if you're aware of them, let's talk more. I think to be futuristic and keep it grounded as well. Leaning into some of the things Dr. Hans talked about, the advancements in some of this technology is really going to be phenomenal and come at a very rapid pace. You've heard of agents, so we're already seeing kind of this agentic rise where you're talking about autonomous, almost digital twin-like intelligence that's able to, write software, compose articles, create works of art, those types of things, and autonomously and collaboratively among a group of agents. I think we'll continue to see that trend come to assist us in our daily lives, not just work, but at home as well. And I think that leaning into maybe that hybrid nature of things, disaggregated compute, we'll call it ambient computing, where there's compute around me that I can tap into, and maybe models and model pipelines, workloads, agents are distributed across that computing infrastructure, is something that I would see as a big trend over the next 5 years that will become a reality sooner than we think.
Well, we hope that you found this conversation to be thought-provoking. I certainly have. It's always great to explore the intersection between AI and us, the human beings in the mix. I'd like to thank Dr. Han for the work that he does in this area, and you also, Marc, over at Dell. I hope the rest of you can tune in to future episodes of AI and Us, because this is truly about AI and us. I'm Dave Nicholson for the Future Group.